Good morning, everyone. I hope I'm audible, please. Let us start. Okay. Am I audible?
Yes, sir.
Okay. All right. So let us now start off with 8085 and just finish off 8085. The basic architecture is required for you to know before we go into 8051 as such. And so this is the 8085 microprocessor from Intel. Okay, it is a 40-pin DIP package. It works at 5 volts. This is the pin diagram of 8085. We have seen the data lines, the address lines, and a few extra lines over here. So these are something called as interrupts and control lines. Okay. We'll move on to the architecture. So every processor or every controller, okay, it has an architecture piece. Okay? It's a very important diagram. So this diagram is like a diagram which will give you the entire layout.
The screen is not visible.
Sir, have you screen shared?
Yeah, yes. All right, so we are starting off with 8085, the internal architecture of 8085. Yeah. So we are talking of something called as the 8085 architecture as such over here, right? So every controller, every processor has something called as the 8085 architecture. Okay, so I was on these slides as such. I was in the 8085 pin configuration slide where we talked that 8085 is a 40-pin DIP. Okay, it has 40 pins, it has address lines, data lines, a few control lines, and few interrupts and all. Okay, so this is what is a processor as such from Intel called as the 8085. It has 16 address lines, 8 data lines as such. Now every controller or every processor, okay, data sheet of that. Okay, so you know what is data sheets, right? So even this 8085 has a data sheet. So this data sheet is by Intel, and they have given an architecture. Okay, so every controller or every processor, it comes with an architecture. So this over here is the architecture of 8085. Fine. In the 8085 architecture, you can see different components as such over here. So ye kya hai? Is it the CPU? Is this a CPU piece? Yeah, what do you think this is? Is this a CPU? What is this entire block, please? The entire block kiska block hai? CPU, right? This is the 8085 block. Okay, so this entire thing is what? This entire thing is what is there inside this chip over here. Okay, so ye chip ke andar, inside this Intel 8085 chip, you have all these different blocks. Fine. All these different blocks are done by means of VLSI technology. Okay, so I told you, right? Chip designers or VLSI chip designers, they come together and they create this very complex architecture as such. Okay, based on this architecture, the chip is being fabricated and then it is brought in front of you by means of what? By means of that 40-pin DIP. Fine. So a 40-pin IC ke andar, you are getting these different components or these different blocks. All right. And how to design this? All of this is part of what is called as VLSI chip designing. Fine. So if you want to have a career in designing the internals of these chips to make it work according to how the instruction set is, then you should become a chip designer or a VLSI chip designer. Okay, and you must select your electives in that way. If you want to make use of this chip, okay, if you want to make use of this chip for different applications, then you are becoming an embedded systems engineer as such. Fine. So please understand the difference between both of them. So these are the main domains in which we are working when we talk of chip level design, right? So it is either chip level designing. So chip level designing means how to create that 40-pin DIP by means of this architecture, or how to create an architecture. And if you want to use this IC, आपको अगर ये IC use करना है for different purposes, then you are saying that you are actually becoming an embedded systems engineer because you are using the chip to create applications as such. All right. So please understand the difference between both and accordingly choose your electives and your career forward. All right. So this is just two, okay, two domains in the EXTC domain. You have different domains: networking, you have signal processing, okay, communication, and RF, all these are different domains. Okay, so you have to gain interest into one of these domains, and afterwards, and then by the third year or the sixth semester, you have to understand that, yeah, this is the career which I would like to pursue. Okay, if you want to remain in core. Okay. All right, so this is the architecture. So every diagram comes with architecture. You can see the pins over here, right? You can see the pins: clock out, ready, RD, bar, WR bar, ALE, S0, S1, IO slash M bar, hold, HLDA. So ये सब क्या है? ये सब pins है. Okay. आपने कहाँ देखा था ये सब pins? You can see this address bus pins. You can see this data and address bus pins. You can see the SID and SOD pins, the trap pin, okay, the INTR pin, INTA pin, RST 5.5 pin, RST 6.5 pin. So ये सब कहाँ है? ये सब, these are all pins, okay? ये सब pins है आपके. These all are pins of your 8085 processor over here. Fine. So you can see these pins which I am showing you on this slide over here. These pins of the 8085 are what you saw in the architecture. Now these pins are connected to what components inside the 8085 is being shown by the architecture. This over here is the architecture. Right. So you can see over here, specifically if I say the A15 to A8, this is connected to the address bus, the higher order address bus. AD7 to AD0 is connected to the lower order address bus. You can see over here, X1, X2, I had told you. X1, X2 is used for your clock frequency. These are connected to some block called as a timing and control, okay? Because clock gives us timing. Okay, so if the microprocessor has to decide that it is 1 second, how will it decide that it is 1 second? They will decide it by means of a clock. Fine. So for example, if you say that I need to blink an LED for 1 second, how does the processor know that it is 1 second? They know it by means of something called as the clock over here. So X1, X2 is the clock. Okay. Then if you want some control signals, these are RD bar, WR bar, ALE. Status may you have S0, S1 are the status lines. Okay. Hold, HLD are used for DMA operations. Okay. So we'll maybe see DMA operations when we are doing microcontrollers as such. Then if you want to reset the processor, okay, so what is the meaning of reset? We know the meaning of reset, right? So when the code is executed serially like this, when you reset, it again goes back to the start of the code, and again it goes like this. Again, I'm going to reset daba diya, फिर से it will go and go to the start of the code. Okay, so reset means you're resetting the entire operation of your processor as such over here. Okay, then you have something called as the interrupt control block over here. So interrupts are used to interrupt the processor. Okay. So for example, if the processor is working, okay, my processor is kaam kar raha hai, okay, it is working as such. Imagine that suddenly you want to say that, okay, I have some external sensor which sends signal, and I want to interrupt the entire execution of my processor. So the sensor will give an interrupt into the processor, as a result of which your execution will break over here. Okay, and it will do something which it has to do. Okay, so this flow is what we are going to see now. Maybe you'll be able to understand this flow better when I teach you the actual how the instructions actually happen. Okay, so an interrupt is required to interrupt the processor. Fine. So for example, if you put your laptop in sleep mode, okay, if you put your laptop in sleep mode, so your system is in sleep mode and it takes minimum current. Now, how do you wake your system again back from sleep? What do you normally do when you want to make a system back from sleep again? What do you normally do, guys? If you want to make your system come back from sleep again, your laptop or your PC?
We press any key.
You press any key, right? So when you press any key or when you press the mouse button and all, what is happening? It's an interrupt which goes to the processor, which tells it that, okay, it is time to wake up. Fine. So if the system is in sleep mode, it is sleeping, okay, it is using minimum resources, and suddenly you have some external device which comes and gives an interrupt, then that external interrupt is going to produce some reactions, and that reaction is being determined by what is the program as such. Fine. So interrupts are required to come and give any interrupt or to interrupt the actual execution of the main program. Then serial IO ports. Okay, it's a very important serial IO ports. Here are where we connect the IO devices. So you can connect your IO devices by means of a few chips, external chips and all. Okay. All right. So ये है आपका main system. All right. Now I had told you, right, that your main system, your main 8085 is divided into 3 parts. What are the 3 parts that we had told you? 8085 का 3 parts क्या था? If you remember, what are the 3 parts of the 8085? I mean, the 3 main bifurcations which we can say.
ALU.
ALU, very good. Then
Control unit.
Okay. Then
Registers.
Okay, very good. Okay. Very nice. I think you are writing it down. Very good. If it is there, otherwise it's coming from memory, then very, very nice. Okay. So ALU, super ALU, registers and control unit. What we have seen till now, we have seen the control and timing unit. Okay. So we have seen this control and timing units, interrupt control and all. Okay. Control. Okay. See control over here. Find serial IO control. So this is the control unit, control and timing unit. So we can say this as control unit and the timing unit. Timing unit is also coming from the X1, X2 CRI. Next is the ALU part of it. Okay, ALU. So when I talk of the ALU, I'm talking of the arithmetic and logic operations unit. Okay, it is the place in which the actual logic of your program occurs. Okay, or your execution occurs. So when I say add 1 plus 2, that 1 plus 2 is getting added inside the accumulator, inside the ALU. So it's ALU is a very complex part of the CPU. So this over here, this region that I'm showing you, this region, we can say it as the ALU part of it. All right. And then you have the registers. You have the individual registers as such. Okay. So individual registers as such are what you can see. So if I say these are the registers as such, all these are the register sets. All right. So you have registers B, C, D, E, H, L, then the stack pointer, then the program counter, then the incrementer and decrementer address latch as such, then the instruction register, then the instruction decoder and machine code, machine cycle encoding. So all these are different. So these are registers. Okay, ये सब registers है. What all you're seeing over here? B, C, D, E, H, L, stack pointer, program counter. You can see all these are called as registers. So when I talk of registers, we know what are registers, right? Registers are basically D flip-flops. So this is a register in the 8085. It is called as the B register. So name is B and it is 8 bits. So it is an 8-bit B register. You have a C register, okay, 8-bit C register. You have the D register, an 8-bit D register. You have an E register, 8-bit. Again, you have an HL register, 8-bit. L register, 8 bits. So साथ में you have something called as the stack pointer. Okay, very important. SP, stack pointer. Then you have something called as a program counter, which we have seen already yesterday. Program counter. Then you have something called as the increment and decrement address latch. Okay, this is also a register as such. Then you have the instruction register. Okay, instruction register, IR that we say. So I had mentioned about the IR yesterday, right? When the data comes into the processor, the instruction goes into the IR, and then from there it is decoded. Right? So this entire block over here, all these are your registers as such. So these are your registers as such, which you're seeing over here. This is the ALU unit, this is the ALU, this is the registers, and these are the other control units. So in total, these form for you what is called as the 8085 internal architecture. That means inside the 8085 chip, you have all these different components. Okay, similarly for 8086, that is the next line of Intel processors. And then when we come to the microcontroller, that is Intel's 8051, we will say that all these are the architectures that are created from Intel. You remember now, you understand now why Intel is such a valued brand as such. It is because they were the first people to have made these architectures. So if you make the architecture, this is just the block diagram architecture. Okay, inside this you have, so for example, each of this one accumulator. Okay, I'll just show you what does one accumulator look like. One accumulator is going to have a lot of flip-flops, a lot of NAND gates, AND gates, whatever. All these things are going to create one accumulator. So creating an accumulator itself is a very big task as such. Okay, so this is an accumulator as you see over here. You have temporary resistors, you have flip-flops. All these are individual components or individual actual flip-flops. All right. So when you go into flip-flops, what creates a flip-flops? What creates a flip-flop, please, guys? What is the inside components of a flip-flop? Yeah, what are the internal components of a flip-flop? So I'm saying the accumulator is made up of flip-flops. What components create for your flip-flop? Have you made a flip-flop from some basic gates, right? Have you done that?
Yes, sir.
Yeah, so you have created a flip-flop by using basic gates, basic AND and NOT gates, right? So you have your universal gates, right? So accumulator is made by flip-flops made by universal gates. What are universal gates made by? What are your AND, OR, and NOT gates made by?
Basic.
Made by? What are the internal components of a AND gate, NOR gate, and all? Boliye. You have used AND gate, OR gate, NOT gate, right? What are the internal components? इसके अंदर क्या है?
Is it transistors?
Yeah, exactly. Superb. It is transistors, right? Transistors are the basic block of your entire digital design, right? So transistors, MOSFETs. Okay. So you can say BJT. Okay. So transistor is also a MOSFET. Okay. So I'm saying a BJT or a MOSFET. Okay. Basically, it's a MOSFET. Right. So these are the components that create for you a universal gate and or not. They come together and create for you a flip-flops. Many flip-flops come together and create for you a accumulator. So people who are going to design the entire chip have to go to this level. That is why we say that a microprocessor has billions of transistors, right? That is the word which we use, right? A microprocessor has billions of transistors as such inside it. Okay? So that is so complex. It is so minute. I mean, the entire designing is it's like a magic, right? It's like magic happening when you say that actual I am having billions of transistors inside this 8085 chip over here. Okay, so I mean it's a revolution technology. You all know it. You all have accepted that also as such. Okay, so this is just 8085, Purana 8085. When you go into the actual Intel processors and all, Pentium and Core processors and all, you will find that it is huge. Okay, all these things are huge as such. So this is architecture. Okay, so every processor comes with the architecture. Okay, so this is which we had seen. All right. So you can see why do I require this? Okay, why do I require these control lines and all? Okay, this SIO by M bar, S0, S1 and all. So whenever I talk, so this is 8085. This is the address bus A5 to A18, A8 to A15. Sorry. Then you have the address lines A0 to A7 and data lines Z0 to A7. So 8085 talks to all your components by means of these address lines. It talks back to the memory and to the 8085 by means of the data lines. Fine. Now, how do I write and how do I read from the data? Okay. So for example, if I want to write to the data, okay, agar mujhe data ko write karna hai, then I need to enable this pin over here. This is the write pin of the memory chip. If I want to read data, then I have to enable this pin on the memory. So fine. So what do we normally do? If I have some data in my memory, so समझो कि ये memory chip है. First of all, understand this diagram. This diagram में क्या है? You have the 8085 over here. Okay. You have the memory over here. So 1 kilobyte memory means what? What is the meaning of 1 kilobyte memory? Means you have 1025 bytes, right? You have 1025 bytes. है कि नहीं? Are you listening to what I'm saying?
Yes, sir.
Yes. Fine. So these are address lines. So you have 1024 address lines as such over here. Right. So these are your memory locations. So I have 1024 memory locations. So here are memory, here are 8085. Since it's a processor, so your memory is different as such. Right. Now, if I want to read data, so समझो कि ये मेरा memory location है. If I want to read data, through my data bus into my processor, then I need to read the data. So I need to make this pin as high. Okay, RD bar. Okay, so if you give a 0 over here, it becomes 1, and then I know memory knows that, okay, it has to read. I need to read data. If I want to write data back into my system, into my memory, into this location maybe, then I need to enable this WR bar. Now, ये enable disable करने के लिए what is required? I am using a what gate is this? It's a NAND gate with inverted inputs in the inverted inputs over here. Okay, so this is a NAND gate with an inverted input over here, and this is going to which lines you see over here? It's going lines WR bar, RD bar, and IO by M bar lines on the 8085. All right. So if I go back to the architecture, you will find that these are the lines. Okay, IO by M bar, RD bar, and WR bar. So these 3 lines as such, they control that whether I should read the data from the memory or I should write data from the memory. Right. So all these things are happening as such, and it is we who need to control this thing. So we have to when actually what happens is that when we write the program, we write the program in such a way that, okay, I need to read some data or write some data. So based on that program, understand this, based on that program which you're writing, the CPU will itself decide what is to be done with these 3 pins. So if I say that, okay, I need to move some data, okay, from the memory, if I say like this, move from the memory to the accumulator. Okay, accumulator is where? Accumulator is there in this thing over here. This is called as the accumulator chip over here inside the ALU. Right. So if I say that, okay, I need to move some data from the memory to the accumulator, then what do we say? We say that it is reading data from the memory, so its RD bar will become high. So who will do that work? The 8085 will do work. When I say that, okay, I need to move some data from the accumulator into the memory. So ये है मेरा accumulator over here और ये है मेरा memory over here. If I want to move some data from the accumulator to the memory, then I am writing data to the memory. So WR bar will become high. So that work is also done by the 8085. Okay, so these are all complex things. Okay, so understand, Lisa, when we actually teach 8085, we teach the entire semester 8085 only. Now what I'm trying to do in front of you is that I am trying to teach you 8085 in 3 lectures. All right. So all these things you have to somehow or the other ingrain. Okay. So these things that I'm telling you, reading data, writing data, all these things come slowly in the 8085 syllabus. But now we are doing the entire 8085 in 2 or 3 lectures so that we at least have an idea of how this thing looks like, 8085. You must know the word 8085. That is very, very important. You must know what is the meaning of 8085. You must know what is the architecture. Okay, these are things which should not go missed. Okay, this is there in the GATE syllabus also, I think, till now, 8085. Okay, so you must not miss out on these things, please. You must not miss out on how the architecture looks like. Even though this is not going to come in exam, at least you have to have an idea that, okay, these are the blocks which are there inside my 8085, and these same blocks will be replicated in 8051 also. Okay. Okay, let us move fast. आगे बढ़ते हैं. This is the entire register array, please. Okay, so I am talking about the register setup. So register setup mein, see, what all registers are there over here. So you have the accumulator, that is this thing over here, this block over here. Then you have the flag registers. So flag is there over here. This is the flag register, please. So I'm talking about registers over here. So accumulator is one register. Then you have the flag register. Then you have the B and C register, that is there over here. B and C over here. Then you have D and E over here. Both are 8 bits. H and L are there over here. H and L are 8 bits. Then you have important few registers called as the program counter and the stack pointer, PC and SP. These are special 16 pointer registers as such. Okay, so we basically have a hold on only these registers. We can control only these registers. Okay, so these are the registers which we can control as such. If I talk about the other registers, if I talk about temporary register, I cannot have a control on that. If I talk of the IR, I don't have a control on that. So that is all done by the 8085. But these are the registers in which we can actually work or read data from. So we can read data from the flag register, we can write data to the accumulator, read from the accumulator, we can write and read from the BC, DE, HL. Okay, so ये सब names है जो दिया हुआ है. To understand your entire operations, if I do 1 plus 2 or 2 plus 3, all these things are getting stored inside these registers and then it moves to the ALU. Okay, so basic things you have to understand. Okay, so that data is stored in the memory. Memory, say it comes back to my CPU. It goes via these registers. It goes into the ALU. I get a result, and the result is stored back into the memory. So this sequence is what is important for you to understand, at least for this 8085 part of it. Fine. So this slide is for 8085. So if you're interested, you can go into the depths of 8085. I will put in this slide on Moodle in a few days. Okay, so this is just the definition of these registers as such. So accumulator, BCD, HL, F register, flag register, program counter, stack pointer, and temporary registers. Okay, so you can see over here, I've told you these registers are only used by the CPU and it is not available to the programmer. So we cannot use these registers. So ये register में क्या करेंगे, हम लोग data store करेंगे and हम लोग इसमें काम करेंगे. Okay, so that is how it will work as such. Okay, let us now look at the meaning of a instruction piece. Okay, instruction piece. Now,
so can you repeat the sequence again?
Okay, sequence again. 1 second. Let me just choose this thing, please. Okay, the sequence is how you write the code, right? You write the code. The code is going to get stored in the memory. Okay, यहाँ आपका memory में आपका code रहेगा, right? Then what is going to happen? The 8085 is going to access the memory by means of the address bus. So it will go to the location of the memory. ठीक है? वो location में क्या है? वो location में you have the instructions. Okay, in binary or hex, right? Then these instructions are taken back from the data bus via the data bus and into the CPU. Okay, so what is happening? 8085, it requests the memory via the address bus. Then the address bus sends the data via the data bus. The data comes and gets stored inside these registers B, C, D, E, H, L, whatever we have seen, or inside the accumulator. And then what happens? The accumulator and along with that the entire ALU, it does the operation. So if I am saying I want to add 1 and 2 together, so that 1 and 2 is brought to the accumulator and all these things happen inside the CPU itself. And then you have a result. That result has to be stored back to my memory. So the result is again taken from the data bus and put inside the memory. So I am reading data and writing data. So I need to enable these pins over here, read and write pins as per the operation which is going to happen. So this is how the architecture of the system looks like actually. Is it clear? Is the flow clear, please?
Yes, sir. Thank you.
Yeah. So I address the memory. Memory से data आता है. Then CPU में कुछ तो काम होता है. Then the result is again stored back into the memory, all displayed into the IO devices. So you need to know only this much. You need to know that okay, 8085 has these things. First thing. Then you need to know that okay, what is the sequence? What is the sequence of the operation that happens? Okay, let us talk about the instructions, please. Okay, instructions. So when I say an instruction means I'm talking of something called as a assembly language. So yesterday we saw, right? We saw C++, higher level language. Then we saw that this C++ is converted by the compiler into what? Into assembly language. And the assembly language is converted into the machine code by means of the assembler. Okay. So now what is happening over here is that you can write your code in two ways. You can either write your code by means of the C++, or you can write codes in assembly. This is what I say, assembly language. So आपने अगर C++ में काम किया है So you will require a compiler which will compile the code into assembly. Assembly will do it into machine code. Or else, if you want to have perfect control over the entire hardware, then you will use assembly language over here. So you can write your program either in C++ or in assembly. We prefer to do it in C when the codes are huge. Okay, so when you're writing a big line of codes and all, so to make things easy, okay, so move AB is difficult to remember than saying, okay, A plus B as such, or int A is equal to 5. So C and Python, all these are higher level languages, which makes things very easy for us. All right. उसके नीचे क्या होता है? उसके नीचे you have something called as the assembly language. Right? So when I say move A, comma B, it is the assembly language. Now, what is the meaning of move A, comma B? Okay, ये हमको समझना है. What is the meaning of move A, comma B? I am saying that when I do move A, comma B, I am saying move the contents of register B into A. Okay, move A, comma B is move the contents of register B into A. Now, what is B and A, please? What is B and A, please? B is this. B contents I'm going to move into A as such. Now, please tell me, ये B और C में data कैसे आएगा? How will data come in register B?
Data bus.
From the data bus. Fine. So, ये जो data है, जो B में है, that data is coming from the data bus, and it is stored where actually पहले? Where is it stored earlier?
Memory.
Memory. Very good. Okay, superb. So, memory में, in some block of the memory, I am giving an instruction move A, comma B. So move A, comma B is actually converted into machine code and put as maybe 6E and maybe B. Okay, so maybe I'll say okay 1, 2. Okay, the meaning of this is move A, comma B. So 6E will tell me okay that I need to move data, and what data? Maybe data 12. So maybe data 12 I'll move into B as such. Okay, and that data is afterwards moved into the accumulator. So your work is only to write what? Your work is only to write move A, comma B. The rest of things will be taken care by the assembler and the machine code. So you have to understand what is the meaning of A, comma B. You're saying that I am going to move data which is in B into A. But B में data आने का, right? कहाँ से आएगा? It will come from the memory and get stored inside the B register. So B register is again where it's over here, please. Okay, so this is the B location. All right. So when I talk of instruction, I talk of move A, comma B. So move A, comma B is my instructions. Very good. So this is move, this is A, and this is B. Now, what are the parts of the instructions, please? When I talk about the parts of the instructions, I have A and B are called as my operands. Okay, please understand this, operands. All right. Move is called as the opcode or operation code, or we say the instructions, or we say mnemonics. Okay, the M is silent, this is mnemonics. So when I talk of instructions, I have move A, comma B. Usme A and B are called as the operands because these are the things which are actually going to operate on the CPU as such, right? So these are the operands. But move is called as the opcode or operation code or instruction or basic word. It is called as the mnemonic. Okay, so you as an engineer are going to do what you as an engineer are going to do, right? This. Okay, so you are going to say like move, okay, A, comma B, okay, move A, comma 5. What is the meaning of move A, comma 5? Matlab? What do you think is going to move A, comma 5?
5 will be moved into A.
What is 5?
Register.
No. Do
Data.
I have it's data directly? Okay, so understand this.
5 data.
Yeah. So when I say move B, comma A means what? I'm going to move the contents of B into A. When I say that I'm going to move A, comma 5, that means I'm going to move the actual binary 5. What is 5? 0, 1, 0, 1. So 0, 1, 0, 1 is directly moved into A. Okay. एंड ये 5 कहाँ स्टोर रहेगा, ये पहले स्टोर है मेमोरी से, सो डायरेक्टली मेमोरी से it is going to move where, it's going to move where from the memory into the
Accumulator.
accumulator. Okay, so memory से सीधा move होगा into accumulator. But if I talk of B, the data is first going to get stored in B and then move into A and all. Okay, so these are called as different addressing modes. Okay, so either you can write like this: move A comma B or move A comma 5. All right. So what do you think should be the actual way in which it happens? I will say, maybe I will say, okay, move B comma 5, then move B to A. Okay. So I normally write it this. Okay, it is like this: B A comma 5. 5 means number 5 is. Okay. So I'm saying move B comma 5 means पहले 5 में B जाएगा, B में 5 जाएगा, fine. Then that B will get stored into A then. All right. So you can see over here, right? You can see very clearly that these are different modes. So either you can write like this or you can write like this. And there are different other ways also. So you can write like this also. You can write move A comma M. Okay. मतलब directly memory से contents will move into A. And what location of the memory is what we'll see. Okay, so there is something called as the HL pair register, which we are going to work with as such. Right, so you can see over here, this is different kinds of operations. Move B comma 5 means immediately I'm putting the data into B. Move B comma A means it is indirectly by means of the register. Move A comma M means it is memory addressing as such. Okay, so there are different things which happening over here. Okay, as such, when you do 8051, we'll try to do all our programs by means of the assembly language itself. Okay, so it's been a while since even I have used assembly language, but since we are doing this course together, so it will be a good revision for us to do assembly language also. Okay, once you move ahead in your career, you will obviously be using C language. Okay, so when you're talking with ARM processors and ARM controllers and all, you will be happy to do things with C language. But there are designers who love to do in assembly language. Okay, so they are experts in assembly language as such, as I can say. They will write the code in assembly language. They will know the exact. So when you write assembly language, you know the exact jumps, you know the exact place at which things happen and all. Okay. All right. So please understand this. Move A comma B. A, B are operands. Move is the code. All right. Now, as you see, I'm talking of what? I'm talking of the. Now I'm going to talk of the opcode or the operation code of the mnemonics. Right. So move is a mnemonic. Move के जैसे there are different kinds of mnemonics, right? You have arithmetic mnemonics: add, subtract, divide, multiply. You have data transfer mnemonics like move, pop, in, out. Logic mnemonics like AND, OR, XOR, NOT. Jump mnemonics like JMP, JZ, and other mnemonics like NOP means no operation as such. ठीक है? So ये सब कौन बनाया? किसने बनाया ये सब? Intel has made this, and Intel has made this mnemonics for what processor? They have made it for the 8085. So 8085 supports all these different mnemonics. Okay, I'll just show you it once. Okay, so these are the mnemonics as such of your 8085. So all these mnemonics, okay, they come together to create what is called as the instruction set of the CPU. So how do you work with the CPU? You work by means of the instruction set as such. Just a second, please. Okay, can you see this, please?
Yes, sir.
Yes, sir.
Yeah, so this is what is given to us by Intel. Okay, so it is Intel's 8085 instruction set. Okay, so we understand what is instruction set, right? So when you talk of instruction set means a number of mnemonics together make up the complete instruction set of the CPU. So all these different operations, move, add, subtract, all these different mnemonics come together to create for us something called as the instruction set of the CPU. This is there for all CPUs. So every CPU means it is there for processor, all microprocessors and all microcontrollers, because all controllers also have a CPU, right? So all controllers have a CPU, all processors are actually CPUs. They all have together something called as the instruction set, which we are seeing over here. All right. So you can see this is the 8085 instruction set. You can see all these different kinds of instructions as you can see over here on the screen. So ACI, ADC, ADC. So आपको ये सब याद रखना नहीं है. So you can work when you're doing your labs and all. You can actually see the data sheet of your 8085, see the instruction set, and based on the instruction set, you will do the operations. Right? You can see so कितने सारे mnemonics है, CMP, CNZ, DA. Okay, so बहुत सारे हैं, J, jump, okay, load, move, push, rotate operations, subtract operations, XOR operations, बहुत सारे operations है ऐसे. And you can see each operations has a code. Okay, so this is the code of the operation. You see CE data. For example, if I do move किधर गया, move इधर गया. Okay, so when I do move M comma register, or maybe I'll say move M comma register means move M comma A, or move M comma B in that form. Okay, or if I say move register comma register means move A comma B. Okay, register means what? A. Register means B, move A comma B. So move operator has this kind of a, you can see these are the, what are these things you're seeing over here? ये सब क्या है आपको लग रहा है? What are these things, please?
Hex code.
Hex code, the machine code, right? You know right what I'm saying? I said, right? C++ से लेके assembly बनता है, assembly से क्या बनता है? You have the machine code, right? So machine code is in hex, right? Or hex or binary. So ये सब आपका hex or binary is. You can see over here. Nice, it is given over here. Okay, so you don't have to actually do the machine code. Machine code will be done by the assembler. तो सब कुछ तो हम लोग नहीं कर सकते ना. We can do what we can do maximum. We'll do up to assembly language. Assembly से machine code में कौन बनाएगा, convert करेगा? It will be done by the assembler. So what does the assembler do? Assembler is going to convert all these different kinds of instructions into the machine code. And these are given to us by Intel. So Intel tells us that, okay, then you write move M comma register, or move register comma M, or move register comma data. So these are, what do you understand about this? Just look at this. If I say move register comma data, what is the meaning of that example? This is what? MVI. What is register? Move register comma data. So register can be A, or I will say maybe B, register B. And what is data? Data is, right, #5. Okay, number 5. So move register comma data. What is move register comma M? I can say, okay, move register comma M means I'll say register, maybe I can say register D comma M. इसका example क्या रहेगा? Move M comma register. Register can be anything. What is the registers we have? B, C, D, E, H, L. So I can say E. It's like this. What is move register comma register? I can say move
A to B.
A to B. Yeah. A is a register, B is a register. So what all registers do you have? You have A, you have BC, you have DE, HL. Okay, and then you have stack pointer SP and program counter. इतने सारे हैं आपके पास जो आप काम कर सकते हैं. Okay, so when I talk of registers, you have B, C, D, memory. Okay, fine. And then you have something called as bytes. Okay, so how many bytes of memory this thing will take? For example, if you do a move A comma B, it will take 1 byte of memory. Move move m comma register will take 1 byte. You can see this 1 byte over here. Move rh comma m, you will say 1 byte of memory as such over here. Then okay, then we have some t states. We'll talk of this afterwards, and machine cycles of. So this fetch and write and all. Okay, and this is sufficient, I think. Just wanted to show you one more thing. Yeah, let's show you this one more image that I'm seeing. Okay, for example, if I say MVI, okay, move a comma 7h, okay, so see over here. If I'm saying MVI a comma 7h, okay, so it's night photograph to have, please. So if I say MVI a comma 7h, what am I saying over here? I am saying move 7h directly onto A. Okay, move the data 7h directly onto A as such. Fine. So when I say MVI a comma 7h, I'm saying you must move the data 7A into 7F into A. Okay, what is this H, please? What is the meaning of this H, please? What is the meaning of H? H क्या है?
Hexadecimal.
Hexadecimal. Okay, उतना ही है. Okay, so this either you can say right like this 16 or H लिखो उसको. सामने से दोनों कोई भी लिख सकते हैं. So when I say MVI a comma 7F, what am I saying over here? I am saying that we need to move 7F into A. So you will write this. You will write in your assembler. You will say I want to move MVI a comma 7F. What does the assembler do? Assembler is going to convert this into machine code. And how does it do? It does by this. So when you do MVI comma a register, you will get, this is the thing, 3E. So 3 is the machine code for MVI A. And then you have the data, other data 7F over here. Similarly, when you do an ADI, okay, add immediate. So ADI 0F means ADI has C6 as the machine code, 0F is the actual data. So ये सब कहाँ स्टोर है guys? Where is this going to get stored? 3E, 7F, 6C, 0F कहाँ स्टोर होने वाला है ये कहाँ स्टोर होने वाला है आपका?
Memory.
In the
Memory.
memory. Very good. And memory से कहाँ जाएगा?
Registers.
Memory से it will go to the CPU, right? That is the best thing. Okay, that is the registers of the CPU or whatever it has to happen. Fine. So when you write the program MVI 7F or when you write the program ADI 0FH, what is happening? Actual में you are storing the data machine code into the CPU, into the memory, and that data is going to go into the CPU. Now, who decides that MVI A is 3E? Who decides ADI is 6C? This is done by Intel itself. Okay. So just okay. So let us just look at MVI. MVI किधर है? MVI is over here. Okay, you can see MVI is over here. MVI A comma 8 bit. Okay, so you can see over here, right? Are you able to see MVI over here?
Yes, sir.
MVI A comma 8 bit. It's not clear, but still, ये है MVI A comma 8 bit. You can see what is the actual machine code over here. This 3E. All right, and that is what you are seeing. That is what you are seeing over here, right? MVI gives us MVI A. It gives us 3E. What is this ADI? Let us see ADI. Okay, let us see if ADI is 6C6. Where is ADI? I have to see. ADI will be ADI. Yeah, ADI you can see over here. ADI, add immediately 8 bits. What is it? It's C6. So ADI is C6. Let us look at one more then. Jump, JMP 9050. Okay, what do you think is jump ka opcode? What do you think is jump ka opcode? Is it C3, 50 or 90?
C3.
C3. ये क्या है? 50, 90 क्या है?
X code.
What is it? It's at is the operand, right? ये operand है इधर ना 50, 90 है कि नहीं? जैसे you have the operand 7F over here and 0F over here, similarly you have the operand over here. Now when I do operation called as LDA, okay, don't understand what is the operation, it is fine. Just know that there is an operation called as JMP and LDA. What is LDA? What is LDA का opcode?
3A.
3A. What is this 88 and 50?
Operand.
Operands. Okay, so use the words properly. So 88 and 50 are the operands, right? LDA is the mnemonic. Opcode का machine code है ये 3A. Let us look at this. JMP has to be C3, LDA has to be 3A. So JMP. Let us look at JMP. Yeah, JMP. You can see C3. JMP is C3. Nice. And what is it? What is the other thing?
LDA.
LDA is 3A. LDA. You can see LDA is 3A. Perfect. Right. So this entire sheet, okay, this entire sheet that you are seeing over here, this will be given to you. Okay. So I still remember when we used to do what is that? When we used to do in my times when we used to do 8085 processors, it was 12 or 15 years back, I think. Okay, so when we had done 8085, we used to actually put these numbers. You can see these numbers, right? So these numbers, we didn't used to. There was no assembler. We didn't use to write the code in assembly. Okay, हम लोग assembly में ये code लिखते नहीं थे. We used to go one more step down and we used to convert the assembly into machine code, and we used to feed this data directly into the processor. Okay, but now what you can do is that now we have nice emulators which can directly emulate this thing. Okay, we can emulate the 8085 or 8086, and we can write by means of these codes as such. So हमको say we have to only go to the machine learning language. But what did we do? Just imagine what we had done. Okay, we wrote this code first of all. We got it verified from our faculty. Then क्या करते थे हम लोग? We used to open up this sheet. ऐसे sheet आता था. This sheet would give us these things, right? We used to get these things, and there were these experimental kits जहाँ पर हम लोग ये feed करते. We used to feed 3E, enter 7F, enter C6, enter 0F, enter, and then we used to end the program, and then we used to see the output. So we used to do this when quite some time back when I had this course of primary microprocessors. We used to do this. Actually, we used to go 3E, 7F. But now we have good enough simulators. I will give you a link of a simulator after the lecture. You can go and simulate a few lines of 8085 and see if it works for you well. Okay, so I hope this is clear. Okay, so what all have you learned today? So you have learned quite a lot of important things. I'm just telling you. So you have learned about the instructions, very important as such. You have learned about the architecture. So architecture, flow, and instructions, all these things are going to be repeated. So ये जो style है हम लोग जो सीखते हैं हम लोग ऐसे सीखेंगे. When you learn 8051 you will learn about the architecture, then you will learn about the different components of the architecture, then you will learn about the instruction set, and then you will learn how to program the device as such. So 8051 is put into two modules. First module is when we actually talk about the architecture. So pura architecture. So 8051 will have its own architecture. We are going to learn about each block of the architecture. Second, we are going to learn about the programming of 8051. So when you learn about the programming of 8051, you will be learning about how the programming happens and what do you think should be the expected output as such. Okay. So just show you this thing. Okay, so this is how things are going to move. Okay, so module 3 mein, you're going to have 8051. Okay, you're going to see the entire architecture and the pin configuration of 8051. So we are going to see everything is there over here also. Serial data input output हम लोगों को अभी भी था. Interrupts ये भी है. Counters and timers अभी भी कर रहा है. Memory organization, that is the registers अभी भी है. Input output ports अभी भी है. CPU timing and machine cycle अभी भी कर रहे हैं हम लोग. So whatever we have learned in 8085, same style we'll use. We'll go with the architecture, we'll go with the CPU timing, input output ports, counters, interrupts, serial data input and output. Same style. उसके बाद क्या करेंगे? Module 4 में we'll be going into the assembly language programming. So we'll be seeing the programming. So you can see addressing modes. I told you ना addressing modes है. Instruction set of 8051. Need of the assembler, cross assembler, assembler directives. So ये सब उसमें आएंगे. Fine. So this is two modules of 8051. इसके बाद you will see again we'll go to ARM. So ARM may be same concept. So again you will be learning about the architecture of ARM. Then you'll be learning about the instruction set of ARM, a few instruction sets. So the style is the same. That is why we all should know 8085. So once you know 8085, you will know what is the style. First, you will have to know the architecture, pin configuration, each block of the architecture, then go into programming. All right. So invest your time in this, please. Invest your time. It will be useful for you in your future, please. Okay. Okay. So we'll stop over here for today. I will take the attendance, please. Okay. How many? Okay. So we are only there for. All right. Fine. So I'll take your attendance, please. Please check into the application, all of you. Are the DSC students over here? Diploma students are there over here? Or you have your exams?
Yes, sir.
Yeah, आज exam है?
हाँ, अभी है.
अच्छा अभी 10 o'clock को 9 o'clock को.
हाँ, 10.
And you have the exams in the next week also?
Next week, but Monday.
Only Monday. So when all do you have exams? Tomorrow? Today then?
Today
Yesterday
and Monday
also.
last.
Okay, you had exam yesterday also?
Day before yesterday.
Day before yesterday. ठीक है. Okay. So what is the exam timing abhi? 9 o'clock? Is
10
exam
to
at
11.
10 to 11. Okay. So we have time, right? Okay. Yes, Sonavane.
Yes, sir.
Shivraj Shetty.
Yes, sir.
Sanskar Kumar.
Yes, sir.
Pranjali Raval.
Yes, sir.
Pooja Verma.
Yes, sir.
Jignesh Harishchandra.
Yes, sir.
Divya.
Yes, sir.
Anushk.
Yes, sir.
Kajal.
Yes, sir.
Okay, thank you very much. We'll meet next Monday, please. Okay, some of you have asked for a few videos of the of these things, extra videos. I will just check for extra videos. I don't have for 8085. 8051 का बहुत सारा है. 8085 I'll just check out and see if I can get a few videos and I will post it on the group itself. And I will also give the link of 8085 emulators where you can emulate these things and see real time. Okay. Shall give you the links of that. So browser में open होता है सीधा straight forward. Fine. Okay. Thank you very much.